Hello everyone, this is Kalpana here. In this video, we're going to see a problem from partial differential equations. So let's get going. Problem: form partial differential equation from z equal to f of x plus iy plus g of x minus iy by eliminating the arbitrary functions f and g. We are given a relation and we are asked to form a partial differential equation by eliminating these arbitrary functions f and g. So let's see. Given z equal to f of x plus iy plus g of x minus iy. Consider as equation number 1. Now let's partially differentiate it. We have to find p, q, r, s and t. We'll find all these. Okay, we'll find p, q, r, t and we'll compare those equations. And if we feel it's okay to find partial differential equations with that 4 equations, we won't find s, otherwise we'll find s also. Okay, let's see. Now I have to find p. P is nothing but partial derivative of z with respect to x, right? So we have to partially differentiate it with respect to x to find p. Partially differentiating one with respect to x, right? Just apply dou by dou x on both sides of the equation. I'll write directly dou z by dou x equal to, here we are partially differentiating with respect to x, so we'll treat y as constant. Partial derivative of f of x plus iy with respect to x is f dash of x plus iy into inner derivative, that is dou by dou x of x plus iy, plus partial derivative of g of x minus iy is g dash of x minus iy into inner derivative dou by dou x of x minus iy, right? This gives us, since we have a notation, dou z by dou x equal to p, right? This gives us p equal to, we'll just replace it by p, otherwise you can just leave it like this. I'll write p, okay, equal to, nothing is wrong in it, just replace p because we are having notations, right? Let's use it. This gives us f dash of x plus iy into partial derivative of x with respect to x is 0. Since y is treated as constant, partial derivative of iy with respect to x is 0. Sorry, partial derivative of x with respect to x is 1, right? Plus partial derivative of iy with respect to x is 0. Plus g dash of x minus iy into partial derivative of x with respect to x is 1 minus partial derivative of iy with respect to x is 0, right? This gives us p equal to 1 plus 0, 1. 1 into f dash is f dash, that is f dash of x plus iy, plus 1 minus 0 is 1. 1 into g dash is g dash of x minus iy. Consider as equation number 2. Fine. Now we got p. Let's find q. Q is nothing but dou z by dou y, right? We need to find partial derivative of z with respect to y. Find partial derivative of 1 with respect to y to find q, right? Partially differentiating one with respect to y. Just apply dou by dou y on both sides of the equation. I'll write directly dou z by dou y equal to, here we are partially differentiating with respect to y, so we'll treat x as constant. This gives us f dash, partial derivative of f of x plus iy is f dash of x plus iy into dou by dou y of inner derivative x plus iy, partial derivative of x plus iy, plus partial derivative of g of x minus iy is g dash of x minus iy into inner derivative dou by dou y of x minus iy, right? This gives us, since we have a notation, dou z by dou y equal to q. Let's replace it by q. We'll get q equal to f dash of x plus iy into partial derivative of x with respect to y is 0 plus I, treat I as constant, okay? I into partial derivative of y with respect to y is 1 plus g dash of x minus iy into partial derivative of x with respect to y is 0 minus I into partial derivative of y with respect to y is 1. This gives us q equal to f dash of x plus iy into I into 1 I plus 0 I, right, plus g dash of x minus iy into I into 1 I, 0 minus I is minus I, okay? So consider it as equation number 3. Now I need to find R and T, right? Our target is to find R and T now. R is nothing but dou square z by dou x square, right? Or we can write this as dou by dou x of dou z by dou x. So R is nothing but partial derivative of P with respect to x. Since dou z by dou x is P, right? So if you find partial derivative of P with respect to x, we'll get R simply. So what we have to do? We have to partially differentiate this 2 with respect to x. Partially differentiating with respect to x. Just apply dou by dou x on both sides of it. You can do directly also. This gives us dou by dou x of P is nothing but dou z by dou x, right? Equal to partial derivative of f dash of x plus iy is f double dash of x plus iy into inner derivative. Partial derivative of x with respect to x is 1 plus partial derivative of constant with respect to x is 0. Here I is constant, okay? Partial derivative of y with respect to x is 0. Somehow or anyhow, you will get partial derivative of y with respect to x 0. Since we are partially differentiating with respect to x, so we will treat y as constant, okay? Already we are treating I as constant here. So you will get partial derivative of a constant with respect to x 0 plus partial derivative of g dash with respect to x is g double dash of x minus iy into inner derivative. Partial derivative of x with respect to x is 1 minus partial derivative of a constant with respect to x is 0. Right? This gives us dou square z by dou x square equal to 1 plus 0 is 1. 1 into f double dash is f double dash. F double dash is nothing but f double dash of x plus iy. Plus 1 minus 0, 1. 1 into g double dash is g double dash. Since r equal to dou square z by dou x square, this gives us r equal to f double dash of x plus iy plus g double dash of x minus iy. We got I here. R here. Consider as equation number 4. We got r equal to f double dash of x plus iy plus g double dash of x minus iy. Equation number 4. Now we need to find t. See here you can also find s also. Okay, you can find s also. But I feel s is not necessary, so I am not finding it. Now we'll find t, which is nothing but dou square y by dou y square, or we can write this as dou by dou y of dou z by dou y. Since we have a notation dou z by dou y is q This gives us dou q by dou y, right? So t is nothing but dou q by dou y, or by finding partial derivative of q with respect to y, we'll find t. We'll get t. Okay. Partially differentiating equation 3 gives t otherwise simply. Let's partially differentiate 3 with respect to y. Partially differentiating 3 with respect to y. Just apply dou by dou y on both sides of 3. This gives us dou q by dou y equal to partial. Here we are partially differentiating with respect to y, so we'll treat x as constant. Here x are constant. Okay, this gives us partial derivative of f of x plus iy is f double dash of x plus iy into inner derivative, that is dou by dou y of x plus iy into this I. Okay, plus partial derivative of g dash with respect to y is g double dash of x minus iy into inner derivative dou by dou y of x minus iy into minus I. This minus I. Okay, this gives us dou by dou y of, you can also write this as, see, we know that q is nothing but dou z by dou y, right? Or just you can write directly here t simply. Okay, this gives us dou square z by dou y square equal to, you can just directly write t here. I'm just trying to make you understand that this gives t, that's it. So that I'm replacing this notation by dou z by dou y. Okay, you can directly write t here because dou q by dou y is nothing but t. Partial derivative of x with respect to y is 0 plus I into partial derivative of y with respect to y is 1 into this I plus g double dash of x minus iy into partial derivative of x with respect to y is 0 minus I into partial derivative of y with respect to y is 1 into minus I. This gives us t, since dou square z by dou y square equal to t. Just replace it by t equal to f double dash of x plus iy into 0, I into 1 is I plus 0 is I, right? You'll get I into this I. Later you'll get I square, which is minus 1. G double dash of x minus iy into I into 1, I, 0 minus I into this minus I. This gives us t equal to f double dash of x plus iy into I square, I into I square plus g double dash of x minus iy into minus plus I into I square, right? This gives us t equal to, since we know that I square equal to minus 1, then you'll get f double dash of x plus iy into minus 1 plus g double dash of x minus iy into minus 1, right? Simply you'll get t equal to minus 1 into f double dash is minus f double dash. G double dash into minus 1 is minus g double dash. Consider as equation number 5. So we got equation number 5, that is t equal to minus f double dash of x plus iy minus g double dash of x minus iy. Now see, observe equation 4 and equation 5. Here you are having plus plus, here you are having minus minus, right? So if you take minus common from these two terms, you will get minus of f double dash plus g double dash, which can be replaced by this r. Simply from 4 and 5, you will get the required partial differential equation. Okay, make a habit of observing all these 5 equations. If we have s also, observe that s also. Okay, better if you are going to give exam, find all these 5. Okay, first find this 4 and then find this s also. Right, now we have equation 5, right? T equal to minus f double dash of x plus iy minus g double dash of x minus iy, right? Here take minus common from these two terms, you'll get minus of f double dash of x plus iy plus g double dash of x minus iy. Since from 4 we have f double dash of x plus iy plus g double dash of x minus iy equal to r, right? Then this becomes t equal to minus of, just replace it by r, t equal to minus r, bring this r to LHS, you'll get r plus t equal to 0, which is the required partial differential equation. Therefore r plus t equal to 0 is the required partial differential equation. This completes the problem. Okay. Okay, let me show you S also. I'll show you S. S is nothing but dou square z by dou x dou y, right? We can write this as in two ways. Dou by dou x of dou z by dou y, or dou by dou y of dou z by dou x. We know that dou z by dou y is q, and we know that dou z by dou x is p. So dou q by dou x gives s, and dou p by dou y gives s. Okay, I'll show you using p because it has extra i's, right? So I'll go for this, it will be much easier. You can also try this, it's not too hard. So I'll find s using partial derivative of p with respect to y. Now we'll partially differentiate p with respect, equation 2 with respect to y. Partially differentiating 2 with respect to y. Just apply dou by dou y on both sides of p. Since we are partially differentiating with respect to y, so we'll treat x as constant here, right? Right. Partial derivative of f dash with respect to y is f double dash into inner derivative, partial derivative of x plus iy with respect to y. Partial derivative of x with respect to y is 0 plus I into partial derivative of y with respect to y is 1 plus partial derivative of g dash with respect to y is g double dash of x minus iy into inner derivative. Partial derivative of x with respect to y is 0 minus I into partial derivative of y with respect to y is 1. Right? This gives us dou p by dou y, or you can just write it as, okay, equal to I into 1, I plus 0 is I. We'll get f double dash of x plus iy into I plus g double dash of x minus iy into I into 1, I, 0 minus I, right? So this gives us dou square z by dou x dou y equal to f double dash of x plus iy into I plus g double dash of x minus iy into minus I, or you can just write this as, what is this, s, right? S equal to I into f double dash of x plus iy plus into minus I into g double dash of x minus iy into I, or you can write I into, there's nothing wrong with it. I wrote I after the f dash and g dash, so I'm just following that pattern. Okay, so this is our s. See, here we have f double dash I minus g double dash I. Okay, you can just observe all these equations and find the required partial differential equation. Let me show you s using dou q by dou x, that is partially differentiating, where is q? Here, q, partially differentiating 3 with respect to x gives s, right? Dou q by dou x equal to, we are partially differentiating with respect to x, so we'll have to treat y as constant. Partial derivative of f dash with respect to x is f double dash of x plus iy into inner derivative. Partial derivative of x with respect to x is 1 plus partial derivative of a constant with respect to x is 0 into I plus partial derivative of g dash with respect to x is g double dash of x minus iy into inner derivative. Partial derivative of x with respect to x is 1 minus partial derivative of a constant with respect to x is 0 into minus I. This gives us dou q by dou x as s equal to f double dash of x plus iy, 1 plus 0 1, 1 into I gives I, 1 minus 0 is 1, 1 into minus I, 1, sorry, plus into minus g double dash of x minus iy into I. You'll get the same thing. Okay, so if you notice, you'll come to know that it's a bit difficult to find the required equation using s, right? Because we have g double dash and f double dash in r and t equations, right? So it will look easy. I mean, it is easy to find equation using 4 and 5 instead of s. If you want, you can try. You may get partial differential equation with s, or you may not get with s. Okay, fine. Well, we have seen a problem from partial differential equations in this video. I hope you'll understand. We'll see you in the next video. Until then, bye bye.